Good evening, and my name is Harith Jesudas, and I am from SMK Pusat Bandar Puchung Satu. Water pollution has become more and more of a frequent issue. Many apathetic individuals, factories, and illegal businesses that operate alongside these water bodies dump tons of toxic chemical or biological waste into the river, rendering the aquatic medium uninhabitable to fish and unusable to us humans. This prompted me to do something about water pollution, and that is how I conceived of the idea of WQMS. WQMS utilizes 6 parameters to put a gauge on the quality of the water that is being tested. The main objective of WQMS is to provide a water quality monitoring system that is easy to use and accessible to everyone without sacrificing accuracy. WQMS relies on an Arduino Uno and a Node MCU ESP8266 Wi-Fi board to provide its IoT functionality. The Arduino accepts inputs from all 6 of the sensors, transfers it to the Node MCU, and the Node MCU wirelessly then transfers it to the Firebase database. The phone or the application then requests for data to the Firebase database, and the Firebase database then provides the application real-time data from the Arduino itself. The sensors on this device are easily detachable, so that if a user would not want to use any one of these parameters or any of these sensors malfunction, the sensors can be easily detached. The importance of WQMS as a device cannot be overstated enough, as it can provide real-time water quality monitoring. Say that if in a situation where a pollutant is present in a river, WQMS can easily pick up the pollutant and send the data in real time and a warning to the management or the individual that is running the system. The WQMS covers a wide range of applications, such as in a fishery, where a farmer might want to use the pH sensor or an electrical conductivity sensor to monitor the pH and salinity of the medium. Furthermore, for tank enthusiasts and aquariums, the dissolved oxygen sensor might be more useful, so that it could measure and maintain and monitor the dissolved oxygen content in the water itself. So we have 6 sensors that are being used in this project. Firstly, the dissolved oxygen probe measures the amount of dissolved oxygen in the water, which is important because all living things depend on oxygen for life. The second probe is the oxidation reduction potential probe, which measures the oxidation or reduction potential of the sample of water that is being tested. This is important in monitoring the activity of bacteria, enzymes, or substances like chlorine, as mentioned before, in the water sample. The third sensor is the electrical conductivity probe. This measures how conductive the sample of water is and is important in determining the concentrations of ions such as sodium ions, potassium ions, or ammonium ions. The fourth probe we have here is the pH probe. The pH probe measures the acidity or alkalinity of the water sample that is being tested, which is important because some marine life can only thrive in certain pH ranges. The turbidity sensor is the 5th sensor that we have here. The turbidity sensor measures the amount of silt or trash that is present in the water sample that is being tested. That might not be picked up by the other 4 sensors that we have discussed previously. Our 6th and last sensor is the temperature sensor. The temperature sensor does not directly measure any parameters, but it provides important temperature compensation to the other probes. Here I've submerged all the sensors into some clear water as a control test. So this is the app that we are working with here. As you can see, all the sensors are emitting normal values because we are testing this in some clear water as a control test. So we have immersed all of our probes into some salt water solution, and as expected, the turbidity and electrical conductivity probes are being triggered. So now we have immersed all of our probes into some polluted water. This here is the water from the backwash of our filter. So if we go over to our app here, we can see that the parameter values for the turbidity sensor and the dissolved oxygen sensor have exceeded the threshold value. Other sensors, though, are giving normal readings as expected. In conclusion, WQMS can be very effective in gauging water quality real time. It is very versatile and can be employed in many different scenarios depending on the user. Thank you for watching.